This is a brief review of exponent properties. So first, something to recall about exponents. If we have a base number raised to a power, for example, x to the third, that means x multiplied by itself 3 times. So exponent is showing us repeated multiplication. And a couple of rules related to exponents. Let's always assume for these rules that x is a positive real number. So multiplication rule, if we have, let's say, x to the third multiplied by x squared, then we can add the exponents to get x to the fifth. So multiplication rule, we add the exponents. The division rule is if we have something like x to the fifth over x to the second, that would give us x to the third, which we get by doing 5 minus 2 in the exponents to get x to the third. So with division, we subtract the exponents. Power of a power would look like x squared raised to the third power. X squared to the third would actually give us x to the sixth. So when we take a power of another power, we multiply the exponents. And then if we have a negative exponent, so for example, x to the negative 5, we take the reciprocal of the base and raise that to the positive version of the number. So negative means take the reciprocal. And then you can see that x to the negative fifth, the exponent became positive when we took the reciprocal. Okay, so a few examples. Example 1, negative 5/6 to the negative second. I would rewrite this as negative 5/6 to the negative 1, all of that squared. Because the negative 1 power is just going to flip that fraction, take the reciprocal of that fraction. So it would turn into 6 over negative 5, then to the second power. And then we square, or we raise to the second power, both of those parts of the fraction. So that would be 6 squared over negative 5 squared, which would give 36 over 25. Okay, next example, example 2. We have the same base, 4 and 4, raised to exponents. So this is an example of the multiplication property, where we're going to keep the same base, 4 times 4, so keep the 4, and then add the exponents, so 6 plus negative 3. 6 plus negative 3 is 3, so that would be 4 to the third power. 4 to the third power is 4 times 4 times 4, which is 64. Example 3, this is an example of the division property. So with division, we subtract the exponents. So in this division example, I did 5 minus 2 to get 3. Here, we're going to have our base of 8, and then subtract the 2 exponents, so negative 5 minus negative 4. Which is really 8 to the negative 5 plus 4, which is 8 to the negative 1. Now we have a negative exponent, so we'll use the negative rule and take the reciprocal of 8. So that would be 1 over 8 to the first power, which is just 1 over 8. Last example is a combination of multiplication and the power of a power rule. So let's do the power first. When we're taking the power of multiple numbers or variables, like in this case we have 3a squared to the power 1/2, we distribute that power to both exponents or to all exponents on the inside. So 3 to the first to the 1/2 would be 3 to the 1/2. A to the second to the 1/2 would be a to the 2 times 1/2. And then this second piece, we'd multiply that outside exponent into both the exponents on the inside. The exponent of the a is 1 since it's not written. So that would be 3 to the second times 3 over 2, and a to the 1 times 3 over 2. Simplifying each of these pieces, that's 3 to the 1/2. And then the power of this first a is 2 times 1/2, which is 1. So that's just a to the 1. 3 to the 2 times 3/2. 2 times 3/2 is 3. So that is 3 to the third. And then a to the 1 times 3/2 is a to the 3/2. And now we're going to use the multiplication rule, where if the base is the same, we can add the exponents. So for our 3's, that would be 3 to the 3.5. And then for our a's, that would be a to the 1 plus 3/2. Which we could simplify to 3 to the 7/2 times a to the 5/2.